Hello everyone, welcome back to another great section of this great tutorial class. Today we are going to be looking at how to evaluate factorial and combination notations. The factorial and combination notation. Remember in the last class we did sigma and pi or multiplication notation. But today we are going to be looking at the factorial and combination notation. Now, there is something you must do before we continue this video. Please, if you have not subscribed to our channel, ensure you do so now. And please, don't distract yourself by any means. Take this class as a very important thing now, because you are going to gain a lot from this class. And lastly, please, if you want to get the full understanding of this class, don't skip any part of this video. All our videos, we have done a lot of videos in mathematics and physics. Please, don't skip any part of the video. Don't skip any part of the videos. As you are watching our videos, watch from the beginning to the end. Don't skip any part of the video. Please take note of that. So please, let's get to business. What we're having here is the first one now. We have factorial and combination notation. So this is the factorial notation. Then this other part is for combination notation. Although we're going to look at some other examples, are still very important things in this topic. So let's look at for factorial notation. This one is for factorial. This one is for factorial. This is for factorial. This one is for factorial. So for factorial notation now, the word n factorial. The word n factorial. Now what is the meaning of n factorial? Look at the write it. N factorial. Where n is any number, where n represents any number, the word n factorial can be mathematically defined as n factorial is equals to n times n minus 1 times n minus 2 until you get to 2 times 1. Until you get to 1, you stop. That is the meaning of n factorial. For all n must be a positive integer. For all n must be a positive integer. You know what I mean? Before this thing will work, look at what I'm saying. If you have n factorial means you will multiply from that number backward until you get to 1. Let's say, what is the meaning of 3 factorial? You multiply from 3 backward until you get to 1. That's a 3 times what? If you remove 1 from 3, what do you times 2 times remove 1 from 2, what do you times 1. When you get to 1, you stop. This is only possible if this n is a positive whole number. But if n is a negative number, if this n here is a negative number like this, minus 3 factorial. If n is a negative number or a fraction, like a fraction factorial, or a fraction, if n is a negative number or a fraction, therefore our n factorial will become the same thing, but it will not end at 1. We will go and end at negative infinity. Go ahead at what? Negative infinity. Please take note of those two things. If n is a positive whole number or a positive integer, you go and end at 1 if you look for the factorial. It means you just multiply from the number backward until you get to 1. Let's say you want to apply formula for this. The first thing, if you ever pick the 3, pick n first. Then you now have the n is 3 here, that's 3 minus 1. 3 minus 1 give you 2. Then times n is 3 minus 2. 3 minus 2 give you 1. Then you stop. Don't say 3 minus 3 because 3 minus 3 will be 0. And you should stop at 1. When you get to 1, you stop. If n is a positive number, because n is a positive number. But for a negative number or a fraction, let's go something like this now. Let's go minus 4 factorial. Something like this. Okay, we already have minus 2 factorial. We'll just solve that there. Let me do minus 2 factorial. Let's go minus 2 factorial now. If you have this one now, this will give you minus 2 first for this one. Then minus 2 minus 1. Then minus 2 minus 2. If you continue doing this, it will not end. The 2 will go and end at minus infinity. That's where you end at. 2 becomes minus infinity. Negative infinity. So for a fraction or a negative number, the answer will go and end at negative infinity. But for a whole number, the answer will end at what? 1. Please take note of that. So this is going to give us now 3 times 2 times 1. So with 3 times 2, 6. 6 times 1, 3 times 6. So 3 factorial is 6, but minus 2 factorial will end at minus infinity. Please take note of that. It's very, very important. So let's look at these examples now. This is what we are going to have. Look at these examples where I go out. Another check. What is 4 factorial? What is mean 4 factorial? That's the first example here. What is mean 4 factorial? So 4 factorial will be, remember, we multiply from 4 backward until you get to 1. So we have 4 times 4 minus 1, 3 times 3 minus 1, 2 times 2 minus 1, 1. It's a very simple thing. Like I said, what is 12 factorial? Multiply from 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, get to 1, stop. Don't multiply from that number backward until you get to 1. So this one will give us, okay, 4 times 3, that is 12. 12 times 2, 24. 24 times 1, 24. So 4 factorial now will be equal to 24. So we are done with this. Now what about minus 5? What about 5 factorial? Okay, not negative 5. What about 5 factorial? We do 5 factorials. About 2, 5 factorial. What are you going to have? 5 factorial will be multiplied from 5 backward to get to 1 times 4 times 3 times 2 times 1. Are you getting it at all? That number factorial, as far as it's a positive whole number, multiply from that number backward to get to 1. That is the formula. That's the formula. So we are going to have 5 times 4, 20. 20 times 3, 60. 60 times 2, 120. 120 times 1, 120. That becomes 5 factorial. Take note of this. Note these ones. Note. 0 factorial is equal to 1. Take note of that. Then 1 factorial is also equal to 1. Take note of those two things. 0 factorial is 1. 1 factorial is equal to 1. Take note of those two things. So let's look at this one. Half factorial. That's one about factorial. That will be, now, fall into this second. We have two formulas here. This one is for fractions and negative number. This one is for whole numbers. Only. Yeah, this one is for fractions and negative number. We're going to add that to infinity. So we're going to have the first thing, the half minus 1 times half minus 2 times dot to get to what? Minus infinity. So we are going to have half times half minus 1 minus half times half minus 2 minus 3 over 2 times dot to get to what? Minus infinity. So expand this one, we are going to end at, the answer will become minus what? Infinity. That's when we want to end at infinity. So let's look at this one there. Look at it. This one is 4 divided by 3 factorial. Not 4 over 3 factorial. Oh, look at it. It's not 4 over 3 everything factorial. No. The factorial affects only the denominator, which is 3. So if I take this one, I'm going to do for me. To be 4 over, what is 3 factorial? 3 times 2 times 1. That will be 4 over 6. 2 here, 2 here, 3. So you have to be 2 over 3. Simple as ABC. Simple as ABC. What about minus 3 factorial? Minus 3 factorial. Minus 3 factorial will be minus 3 minus 3 minus 1 minus 3 minus 2 minus 3 minus 3 until you get to negative infinity. So you get to go and end at negative infinity. We have minus 3 times minus 3 minus 1, that is minus 4, minus 5, minus 6 times dot to end at what? Go and end at negative infinity. Go and end at negative minus infinity. Go and end at minus infinity. Same thing with this one. Same thing with this. That will be minus 4, then minus 4, minus 1, minus 4, minus 2. Dot to end at what? Negative infinity. That will be minus 4 times what? Minus 5 times minus 6 times dot and that negative infinity. That's how it becomes minus infinity. So what is another one? It's negative infinity. Negative infinity. Then what about this one? 4 factorial over 2. It's not 4 over 2 factorial. It's just 4 factorial over 2. Don't want to use mistake to say 4 divided by 2. That is 2 factorial. No. This 4 factorial is having a different property from this. This is not like whole number, but this one is in notation, factorial notation. This one is different. This one is not just 4. This 4 has been influenced by what we call the factorial notation. It's not just ordinary 4. So it has been energized or elevated from 4 to another number by this factorial that is done there. So this 4 factorial that is as 4 times, since it is a whole number, 4 times 3 times 2 times 1 divided by 2 factorial is just 2. So you see, 2 to 2, then 4 times 3 is 12. 12 times 1, 12. That's what we're going to have there. So this is how we run factorials. This is how to solve factorial. So please take note of that. It's very, very important. You have a negative number, you have a positive whole number, a fraction. I'll show you how to solve them. Fractions and negative numbers, we're going to end at minus infinity. That's how we become negative infinity. Then, ordinary number is just a number that is positive. We're going to end at 1. Take note of that. Then, 0 factorial is 1. 1 factorial is 1. So, let's move to combination now. Let me go to combination. Combination. Now, take note of this. The definition. Now, the word n combination arrow. The word n combination arrow. That is n combination arrow. N combination arrow can be defined mathematically as, look at the symbol. This means n CR. That this one is n combination arrow. Or you can also write it like this, n combination arrow. So if you want to write combination, let's say you write it like this, n combination arrow, or you write it like this, n combination arrow. It's not n combined with arrow, no, you say it's called n combination arrow. Yeah. The word n combination arrow can be defined as n combination arrow is equals to n factorial. Have you done factorial before? Yes. N factorial divided by n minus arrow factorial, then times arrow factorial. Times arrow factorial. Times arrow what? Factorial. Times arrow factorial. So this is the definition. So example 1 now, look at example 1. It says what is 4 combination 2? That's the first question. What is 4 combination 2? 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 Now 4 combination 2 will be, look at n combination r, n factorial first. 4 combination 1 will be, what will we write 4 factorial first? So 4 is n here. Then divided by 4 minus 2 factorial. N minus r factorial. Then times what? R factorial, which is downside, and 2 factorial. That will give us, what is 4 factorial? That's 4 times 3 times 2 times 1. Then what is 4 minus 2? What is 4? Okay, let's not forget, let us do. What is 4 minus 2? That is 2 factorial times. What is factorial? 2 times 1. That will be 2 cancel 2. 4 times that is 12 over. What is factorial? 2 times 1 times 1 again. That is, okay, 1 times 1 times 2, that is 12 over 2. 12 over 2. That will be equal to 6. So 4 combination 2 is actually equal to 6. That's the answer. Then what about 50 combination 0? That will be n factorial is 50 factorial over 50 minus 0 factorial. 50 minus 0 factorial, then times 0 factorial. That will be 50 factorial over 50 minus 0 is 50 factorial. 50 minus 0 is 50 factorial. Then what is 0 factorial? That's 1. That's 1. That will give us 50 factorial will cancel 50 factorial since they are the same thing. Not 50 cancel 50 factorial. 50 factorial and 50 factorial are the same thing. We cancel each other. Then 1 divided by 1. 1. So everything now becomes 1. That's how we want. Then next, half combination 1. What is half combination 1? So we are going to another important question. What is half combination 1? What is the meaning of half? I say half combination 1. What do I do? What is the meaning of half combination 1? So remember, look how to do this one. When n is either a negative number or a fraction, the formula will still work. The formula will still work. But we're going to use a strategy to get the answer. So look at it. Now, what's the formula? Put the formula n. N is half here. Half factorial divided by half minus 1 factorial, then times 1 factorial. That's the formula. N factorial over n minus arrow factorial, then times arrow factorial. The formula that I do have, you check what you have here. After you have gotten the formula, then you check the denominator. What is inside this bracket? We are having half minus 1. Then you will go to the numerator and expand it until you get to what you have inside this bracket. Then stop. Go on. What to expand? Remember, I want to expand n factorial to be n minus 1, n minus 1, so on. So if I want to expand half factorial now to be half times half minus 1. Now remember I said when you get to what is here, you stop. So check what is here. We have half minus 1. Half minus 1, you stop. Factorial. Then over half minus 1 factorial. Then what is 1 factorial? 1. So if you check very well now, our problem in this question actually is this one. So this problem we cancel this other problem. So the problem will go. So we have like this problem cancel problem. See that the same thing. Look at it. Half minus 1 factorial. Half minus 1. Like I said, we will cancel out. Then what we have will be half then over 1. Half here and 1 here. What is half over 1? Half. Answer. Half over 1 is half. Answer. Half over 1. Half. Answer. So we have some factorial, we have some combination. So we have 0 factorial 1, 1 factorial 1. We have some combination you also get from the question that you might not need to actually solve that one. I will give you now. If you don't look at the question, you don't get the answer directly. We have some combination like that. Like when you have n combination n combination 1, n combination 0. Let me give you all those shortcuts now before we move on to other important questions. Alright, let's look at more examples under factorial combination issues. So look at what we have here. Now we're going to solve all these questions in case it's so take note of the following. Please take note of the following. Take note of the following. If you have n combination n, the answer will be equal to 1. Take note of that. You have n combination n. If both n, these two things here, they are the same thing, the answer will be equal to 1. Then you have n combination 0. Answer is 1. If you have n combination 1, the answer will be n. For example, now, let's say 4 combination 1, the answer will be 4. I don't know if you understand what I'm trying to say. As long as you are combination it with 1, it is combination 1. Any number combination 1, the answer will be that number. Any number combination itself, the answer will be 1. For example, now, 4 combination 4. As long as what is here, they are the same, the answer will be 1. This is what that is. But 4 combination 1, the answer will be 4. For example, now, minus half combination 1, the answer will be minus half. As long as it's combination 1, the answer will be that number. So if I say half or let's say 3 combination 3, what is the same thing? The answer will be 1. When it's 3 combination 1, the answer will be that thing. That's that number itself. Think of that, it's very, very important. So instead of dividing this with or this one, n combination n 1, n combination n number combination 0 1, n number combination 1, that number itself. So let's take one minus 3 combination 1. Any number combination 1, the answer will be that number. You can prove this, you prove this. Okay, let's prove this after you see it. Minus 3 combination 1 will be minus 3 factorial, minus 3 factorial, then over minus 3 minus 1 factorial, then times 1 factorial. So what you do here, remember, if n is fraction or negative number, what you do, you will express the numerator. You will express, take note of that. If n is a negative number or a fraction, not arrow. If arrow is a negative number or a fraction, the answer will go to infinity. It's forbidden for arrow to be a negative number or fraction, or the answer will be, you don't need the answer to infinity because the denominator will have no end. The number will go to infinity. And any number divided by infinity from limit is 0. The number by infinity is 0. So, remember what we are trying to prove. We are trying to prove that this one is 1. So, what you do here, if you have n to be a negative number, you have n to be a negative number or a fraction. This is how you solve this one. You don't want to express the numerator until you get to what you have in the denominator. Like we did for half. We did for half. So you express this the numerator until you get to the denominator. That's what you do. So let's express it on minus half, minus 3, then minus 3, minus 1, minus 3, minus 1. People will have minus 3, minus 1 and you solve. Then over minus 3, minus 1, factorial, then times. What is 1 factorial? 1. This will go with this. So automatically the answer will become minus 3 divided by 1. Minus 3. So any number combination 1 is that number. But any number combination itself will be equal to 1. So and ensure that the two numbers should be positive whole numbers. But if it's not positive whole numbers, it will still be 1. It will still be 1. It still be 1. Any number combination set will be 1. So that's what is said that we have the answer will be 1. So let's do for this. Any number combination 0 set is 1. So 100 combination 0 will be 1. 100 combination 0 will be 1. So let's look at this. Let's try and prove this to see if it's 1. We have that will be 100 factorial divided by 100 minus 0 factorial and 0 factorial. That will be 100 factorial divided by what is 100 minus 0? 100 factorial. Then what is 0 factorial? 100 into 100. 1 over 1. So the answer will be 1. So please take note of that. It's very, very important. Then what about this one? Minus 1 combination 3. Take note, this one is not 1. Don't say the answer will be minus 1. This one don't have any relation. So we also solve now. We use the formula. We use n factorial, whereby n minus r factorial, then times r factorial. N is equal to minus 1, r is equal to 3. We have minus 1 factorial, then over minus 1 minus 3 factorial, then times 3 factorial. Then you check what do you have here? Minus 1 minus 3. So you are going to express this numerator to get to minus 1 minus 3 to solve. You are going to have minus 1, minus 1 minus 1, minus 1 minus 2. Then we have minus 1 minus 3 and so on. Why are we stopping here? Because that's what we have here. So we are stopping there. Then let's look at this. We have minus 1 minus 3 factorial. What is it factorial? 3 times 2 times 1. That's 3 factorial. So this one, go with this. And we're going to be having minus 1 times minus 1 minus 2, that's minus 2, times minus 1 minus 2, that's minus 3, and over 2 times 3, that's 6. That's 6. So minus 1 times that's plus 2, times this one, minus 6 over 6. That's all minus 1. Answer. So to do this, we have to have minus 1. But I'm going to say, it is not because we have minus 1, that's why the answer is minus 1. Please, it's not because we have minus 1 there, that particular answer becomes minus 1. Just ignore that. I'll do it that way. So the answer unfortunately gave us minus 1. So we take it like that way. The any number combination 0 is 1. So you can go and put this one to see and get the answer. Any number combination 0, 1. Remember, any number combination 0, 1. Any number combination itself, 1. Any number combination 1, that number. Ignore that one. So this one is minus 1 combination 4. You see, we have minus 1 combination 3. We have the minus 1. Then we have minus 1 combination 4. Then we use the answer minus 1. Don't say that. So I will give this one as class work. Class work. Class work. So do this one now and tell me the answer. Ensure you do it well. So we are going to remember before I express the numerator to get what you have here, you cancel out. and simplify to get the final answer. So do that. Let me see what you are going to have. So if you solve this very well, you are going to have 1 as your answer. So let me give you another class work. Let's look at another class work. Another class work. Do half combination 3. Half combination 3. Try this one. Half combination 3. I did half combination 1 before. So do half combination 3. The same way you did this. Express the numerator to get what you have here. You cancel out. Simplify the rest. Just simplify the rest. So I'm sure you did very well. So do it. Let me give you time to do that. So take your time, do it. So let me just give you it. It will be half factorial over half minus 3 factorial times 3 factorial. So you are going to express this numerator now to get to half minus 3 and you stop and you cancel out. You have to divide both what you have there and what you don't have there to get the final answer. So try it, check and see. Try and see if you can do it. It's very, very important. Alright, if you do this very well, you're going to have 1/16 as your final answer. Please, you can watch this video over and over again in order to get the full details of everything. Please ensure you know this factorial combination to the fullest. Please and please ensure you watch the video, ensure you understand. Don't skip parts of the videos. I'll see you guys in our next class. Thank you. God bless you. Thank you.